Aloha, Richard Halverson here. This is ITS128, and this may be the last video of the semester. I'm going to give you some hints on the final project, on the DNA project. So let me share my screen. Share the screen here, and we are okay. So with this is a a problem that actually will be presented at the Special Interest Group in Computer Science Education 2020 conference in March. And uh, basically it's a DNA analysis program. And what you need to do is you are given some DNA strings. These are some DNA strings from some people, and you need to find the longest string of this and this and this in each one of these, and figure out who they are. And this here says how many. If the string has 5 of these and 2 of these and 8 of these, then you know it's Alice. If it's 3, 7, and 4, then you know it's Bob. If it's 6, 1, and 5, then you know it's Charlie. And if it's and it may be nobody. Okay, so we have strings here of each of the folks, and so these are for testing. And so what you have to do is you have to write a program that will match these strings to these people. Okay, so I'm going to give you some hints on how to accomplish this. All right, so first of all, let me just show you how this program should work. Okay, so I'm going to run the program. I've got it written here. Not that. It's Python. Let's see. Do I actually have it here? No. Python DNA.py. Okay, and so I enter the DNA string, and to do that, I'm going to put this over here and put this maybe like this, and put this down here. Now I'm going to put it over here. All right, so let me just copy Alice here. Okay, so I'm just going to copy Alice, see if I can do it this way. Okay, copy, and then over here I'm going to paste Alice. Control V, and it says it matches Alice. 528. 528. Let's try this one, and I'm going to run it again. Paste, and it says it matches Charlie, which is correct. For this one, I actually don't have anything in there. It doesn't say anything. You have to, in yours, you have to say, sorry, no match. Okay, no match. All right, so this is basically how your program should work. And so what I'm going to do is I'm going to start with, I'm going to break the program up into three parts. And let's see, I have some notes around here someplace. Hold on a second here. Is it here? No. My notes disappeared. I got this one. This over here. Oh, I have that here. Okay, so I gotta make a second. How do I make a second version of this? Here we go. All right. So I'm gonna call this one find match. The first thing we got to know how to do is, wait a minute, is that the one yeah, find match. Okay, so I'm going to put that on the desktop. I'm going to call it find match.py. Sure. Okay, so Oh, I see the problem here. Never mind. Okay. All right. So in Find Match, we have a database that looks like this. Okay, we're copying it from here. We have this database here, and the system will ask for the DNA string. So it'll ask for DNA. See, we can just do it this way. DNA equals input this, which is enter a DNA string. Okay, so we ask it to enter a DNA string, and then it does something, and it'll return like a profile. So I'm going to call it a prof for profile, and it'll be something like 528. Okay, and that'll be and that would be Alice. Okay, it could be prof. It could be prof is equal to this 374, which is Bob. Okay, so these are the test ones, and then what I want to do is based on so and this right here will be code to compute profile from DNA string entered, and we're also going to be using this too. So this is the array that contains the sequences. So this is going to be for the first number. This will be the second number. The count, the longest string of these, and this will be the third one. All right. And then from here, we're going to want to loop through and test to see if this thing matches this, or it matches this, or it matches this, or it matches nothing. Okay, so let's make a little loop here, and I'm going to do, let's see, I think I'm going to loop through these by index. So 4, and I'm going to P. I'll use P for person, in the range of the length of the DNA database. Okay, so it's this is this, and the length is going to be the outside, the rows. So this is row 1, and this is row 2, and this is row 3, and the index would be 0, 1, and 2, of course. And so the length of the DNA database is 3. So this is going to be for each P in the range of 3, so it's going to be 0, 1, or 2. And in that, we're going to have a loop here, and it's going to loop through, these 1, 0, 1, and 2. So we can do for I in the range of the length of str sequences, and that's going to be also going to be the size of this. Okay, so what we're going to do is we're going to test this with this, and then we're going to test this with this, the second one, the third one, So this is going to loop through, each of these 1, 2, and 3. Okay, so this is going to be that loop, and basically we're going to test if the DNA database of P, and that's going to say is it this one or this one or this one, but we want to do I plus 1. Does that match, or does that not match the profile of I? So and so profile, so this is going to go 0, 1, and 2. So this will go 0, 1, and 2. This will go 0, 1, and 2. And this is going to go 1, 2, and 3, which is what we want, because 0 is the name. So we want to go 1, 2, and 3. So this is going to loop for I going from, the outside loop is going to first test this one, then it's going to test this one, then it's going to test this one. And the inside loop is going to test this one to this one, and this one to this one, this one, and this one to this one, you see. So, and what we're going to do is we'll start out assuming that there's a match. And if one of the numbers does not match up, then we would say that match equals false. Okay, so that's that outer loop. And then if we make it all the way through 0, 1, and 2, or 0, 1, and 2, and this is never executed, then that means the numbers match up, which means if we have a match, then we can print that there's a match. Matches, and we will just we can just print out which row it matches. Okay, so we'll just do DNA. Let's see, DNA database. Which row it is? P, right? Yeah, P. It's this one. So we will loop through all the P's. Alice is the first one, Bob is the second one, Charlie's the third one, and for each one of these we will test to see if there's a match, and for there to be a match it's got to loop through all three of the numbers, 0, 1, and 2, and they have to be equal. If they're not equal, this match variable gets set to false, and when we're done looping through all three of them, if the match variable is still true, then we know there's a match. So we can run this, and the first time we run it, it's going to be on Bob. So let's see if this outputs Bob here. See if it outputs that, because it's going to see if it outputs this whole thing here. So I'm going to save this, and I'm going to Python. What is this? What did I call this? Find match. .py, and it says unexpected end of file, line 18. Why would it be an unexpected end of file? It didn't ask me. Am I doing the right? Okay, it didn't ask me for this. Let's see. It could be this. All right, save. Let's try it again. All right, enter a DNA string. It doesn't matter what I enter because it doesn't really do anything. And it said matches Bob 374. Okay, because that's what this was. That's what the profile was. Let's say the profile is not this, but Alice. Oops. What's going on? Oops. Cut. Paste. This now it should just say Alice. Alice. Okay, great. What happens if we print out the profile first? Print profile. Okay. Okay. Right. Good. Print profile. Okay. All right. So so that is how that's the very ending part. Oh no, you need to put something in there. So it so if there's no match at all, like if it's something that's not anything at all, this thing doesn't, you notice it doesn't print anything here. And so you need to take care of that case. You need to say there's no match. All right, so so we have the part where it reads it in, and so now let's try to find some code. Let's work on the code here to compute the profile from the DNA string. Okay, so what we're going to do is Okay, so next we're going to figure out what kind of code would go in here, and what this code has to do is it has to, so it's got a DNA string, and for each STR sequence, for each STR sequence, you need to find the longest string in the DNA string. Okay, find the longest STR sequence. In the DNA string. Okay, so you're going to have some sort of loop. Okay, and so that's what we're going to work on now. And so I'm going to call that one. I'm going to start a new file here because I don't want to you know, give everything away. So let's just create a new file here, and I'm going to call this file the profile string, py. Oh, where did I save it? Now I want to save it. Save as. I want to save this on the desktop. Okay. Profile string. And so we're going to start out with something like something that computes the longest match. And I'll come back to this later, but we're going to input some sort of sequence, and there's going to be some sort of STR subsequence that we're going to count how many of those are in there. And so right now I'm just going to put in some bogus code, and I'm going to say if the STR SEQ is equal to AGAT, then return a 1, and I'm going to go 2, 3, 4. Boy, this is nuts. If it's AATG, I'm going to have it return a 2. This is just for testing purposes. If it is TATC, I'm going to have it return a 3. Otherwise, it's going to return a 4. Okay, this is just testing. And then see, let me add this. Well, let me add these two things. I'm not going to need this one. Let me add the add DNA string. Throw that in there. So it's going to have something like that, and then I'm going to have I'm going to create a profile array, just a profile array, and I'm going to loop through all these, and I'm going to test the DNA sequence with the string sequence, which is one of these. So that's going to look like 4. I'm going to say S in this for all of the strings in that. Let's see. Let me print it out. Print. I'm going to just print this out. Find longest sequence of S's of that. Uh, and it's going to be print, and I'm just going to print it out. Let's see. Let me. It's going to return a number, so it's going to say count. Count is equal to longest match of DNA, comma S. S is this. DNA is this, what's entered in, however, and that's going to be passed in here, but it doesn't do anything, and we will deal with that a little bit later. Right now, it's just going to pass in this sequence, which is this S, which is going to be one of these, the first this, then this, then this, and it's going to compute the CNT number. I'm going to put this up here, and I'm going to say the longest sequence of S is CNT. And then at the end, I'm going to print this prof. See what it looks like. Okay, let's just see what this looks like. Let me save this, and let me say profile string. Profile. Let me say Python profile string .py, and it says blah blah blah. Longest sequence of AGAT is 1. Longest sequence of that is 2. Then I got messed up here. TATC returns what? Oh, E. Oh, I know a lot of you saw that, but I didn't. Let's try this again. Okay. Now, this did not work. Oh, because I didn't do anything with it. I need to do something with it. I'm going to do prof append parentheses CNT. How's that? So that'll create this array, this profile array. Save this. So it found the longest sequence of AGAT is 1, AATG is 2, and this is what the profile string looks like. So we're going to end up trying to match this up with this. Okay, so now we actually have a profile string here. So I could do something like copy this. This could be copied over to here. And this is where we compute the thing. So we could copy this. Let's print it out over here. Just going to put it here. So anyway, I'm not going to run this. The last thing we got to do is we got to mess with this. We got to figure out this program up here. Okay, so I'm going to start a new, maybe I'll just save this. Maybe I'll save this. I'll come back to it later. I'm going to start a new one called find longest match. Def longest match sequence. Subsuite sequence. This is the str. Okay. And I'm going to save this as longest match .py. All right, so longest match.py. Okay, so for this one, what we're going to do is we're going to first, okay, let's say we're starting with AGAT. So I'm going to do a Control F here, and what we see here is first I'm going to find the first AGAT. Okay, so let's say I'm working on this string here. Okay, let me just widen this up. And let's say I'm looking for AGATs. The first thing, this is my strategy. First, I'm going to find the first AGAT, and that would be this one. And then I'm going to count how many AGATs in a row come after that. They have to be right up next to each other. So AGAT is 4 characters long. So I've got AGAT here, and then right starting 4 characters later, there's got to be another AGAT. And then right 4 characters after that, there's got to be another AGAT. And I keep counting how far I go until I come to the 4 characters after the last one, and it's not AGAT. Okay? And so this one would be 5. There's 5 of them in a row. And there happens to be, is there another one? No, there's not. There's no other AGATs. Okay, so now this one here, the answer is 1, 2, 3, 4, 5, 6 in a row. It's this one here. And then there's also 3 down here, but those don't count because it's the longest string. So Charlie, for Charlie, the longest string is 6. So that's why this matches up here. Okay, so let's try to write this code. So first of all, let's figure out what the length of the subsequence is. What the length of this is, because this is how, this is how I add that length, and I start right afterwards to check the next 4 strings. So I'm going to call sub length is equal to length of subsequence. And then what I'm going to do is I'm going to have an outside thing where I count sequences. Okay, so first of all, let me find the first sequence. And so let me find the index of that. Index of sequence dot find subsequence. Okay, so I'm finding the index of this inside this. So what that's going to do is that's going to find me the index of what this is right here. And I don't know what this is. In fact, I think I can figure out what this is. Let me copy this over here. And I'm going to do ... paste ... okay, quote. Okay, so AGAT is AGAT is right here. Okay, so this is, it looks like these are the numbers up here. This would be 66, I think. So so this is going to be 66 if it's looking for AGAT. So this finds the index of AGAT in sequence. So this is going to be 66. And then we can do while. Okay, so what's going to happen now is we're going to loop looking for further sequences down the line. This is the first one. Then we're going to try to find this one and find this one and so on. And when we don't find it, it's going to return a -1. So I'm going to say returns -1 if not found. Okay, so the reason I say that is because that's going to be the termination condition of the loop here. So I'm going to do while I is greater than or equal to 0. That means we're still locating these subsequences. Well, while this is true, then okay, we found the first one, so I'm going to say CNT, it'll be a count. We found the first one, and let's find the next one. Let's call it I2 equals sequence of find the subsequence, and this time we're going to start at I plus sublength, this. So what this means is this is where we start looking. And what this is this is going to be I 66 plus 4, which is going to be 70, you see. So it starts looking for the next one right afterwards. What did I just do? Okay. It starts looking at the next one right afterwards. And that's exactly what we want. So if we want to see, okay, so we have I, we have the first one, and this is going to be 66. And we have the first one. And then we find the next one. And if I2, okay, this is where we're starting. Now, if it turns out that I2, while I2 is actually equal to I plus sublen, in other words, if it's right there, you see, this is going to return wherever the next one is, and this is the lowest number that it can be, but it can be higher. If it's higher than this, then we've broken the string. Okay, but if it is exactly this, then we're still counting the string. So while I2 is exactly the length of subsequence of this str past the previous one, if that's true, then we can increment the count. And let's set I equal I2 and continue. And so we set I2 equal to this again. We set I equal to I2. We set I2 equal to this. And we continue this loop here. This loop continues until this is no longer true. So it's going to continue this AGAT starting at 66. It's going to keep on going, this one, then this one, then this one, then this one, then this one, and then it's not going to find any more, so it's going to return -1. So at the end, so after it has found the fifth one, comes back around again, this is going to be -1. So I2 is going to be -1. So this is going to fail, and it's going to so it's going to continue past the loop, and I have to keep track of what the longest string was. So let's start out by saying that. So let's call it the best string. Start out with the best is equal to 0, and if we go through this loop a few times, and when we found that the count is going to be equal to the longest string that we just found. So if count is greater than best, then set best equal to count. And then let's set I equal to, this is either going to be -1 or it's going to be someplace farther down. Like, for example, in this case, the first one's going to be here, and then it's going to miss this one, and so the I2 will equal here, but it's not equal to I plus the length of AGAT. It's going to be farther down. So at that point, we're going to set, at this point, we set I equal to I2. And we start this loop over again. Okay? And once this returns -1, because it can't find any more subsequences, this is going to be -1, and then this is going to be -1, and then this is going to fail, and then we're done. So right here we can return whatever best was. So this is how we find the longest match. So so let's see how we test this. Let's define these str sequences here. It's just going to be this. And let's read in a DNA string. That's just going to look something like this. And let's print. Let's just test this. So let's start with the first one. Let's go print. And I'm just going to do this. I'm going to do AGAT, the longest match, this thing. DNA is the sequence, and the substring is, I'm just going to do this. I'm not going to. Okay, so so I'm going to input a DNA string, and it's going to tell me the longest match of AGAT, and let's do AATG, and let's do TATC. Okay, so with this little program, I'm going to input a DNA string, and then it's going to find the longest match of AGAT, and the longest match of AATG, and the longest match of TATC. And that's exactly what our profile is. So once we're done with this, we should be able to put that right into here, wherever this, put that right here. And then we should be able to hook that up. Did I? Profile string. Did I have something in here? Oh. Yes, I had that in there. That's right. Okay, anyway. All right. So let's test this. Save this. And I'm going to go, let's put this up a little bit so you can see it better. Python longest match.py print. Ooh, yes. Oh, gotta end these parens. Okay, this is gonna return a number, but I think that'll be okay. Let's try this. Enter a DNA string. Let's try Alice. Copy and paste. Paste. Enter. And we have 5, 2, and 8. And that's exactly what Alice is, I'm quite sure. Alice is 5, 2, and 8. Let's try Bob. Copy Bob. Copy. And I can go run this again and paste and enter. And I've got 3, 7 and 4, and that's 3, 7, and 4. Lo and behold, it's Bob. All right, so so you can see how that works. This is how we can get back. This is going to be the first one. This is going to be the second one. This is going to be the third one. Instead of putting this here, you're going to do something like, you know, str sequences. I don't know, something like that or something, except for you're going to have a loop here. You're probably going to have a loop here, just like this. str sequences, and you loop through here. And this is going to be, it should be longest matches, longest whatever. Obviously, it's going to match this. So that'll go in there, and you should be able to then go back here and plug that in here. Put that in here, and put this where you build up the profile here, and print that out there, and then you won't need this anymore. Get rid of that, and because you'll have the profile, print it out. You don't even need to print it out. And then you can loop through here, and this thing, after you have the profile, which is, you know, these three numbers, but in something that looks like that, something that looks like this, and then you match it up with these people, and you're able to display out whether it's you know, Bob, Alice, or Charlie. All right, so I hope that helps you with the DNA assignment. You should be able to put that together, and then finish everything up, and you're done with the course. And I hope to see you next semester. Thanks for. Oh, if you have any questions, just email me or text me 808-371-7424, or email me richard.h@hawaii.edu if you need anything. Just let me know. Thanks for watching.